Hi everybody, my name is Amelia Ortiz Gil, and today I am going to show you how we have been creating 3D tactile globes of the rocky planets at the Astronomical Observatory of the University of Valencia in Spain. These globes are also part of the International Astronomical Union's Inspiring Stars exhibition. So in 2019, the IAU became 100 years old. There were many celebrations, and one of them was a 3-day flagship event that took place at Brussels. And you can see in the picture here the group of people that met during that flagship event. There were talks about astronomy and also about the relationship of astronomy with development, inclusion, and education. Among the activities that were organized to commemorate the centenary of the Union, there were 2 exhibitions. One of them was the Above and Beyond exhibition that was about reflecting about the enormous changes and progresses that the field of astronomy has experienced since 1919, starting with the discovery of the expansion of the universe up to the recent and long-awaited detection of the gravitational waves. The second exhibition was an effort to celebrate astronomy as a science that promotes and addresses diversity, and it was called Inspiring Stars. It consists of 5 panels that you can see in the slide. They show how astronomy is made by international collaborations and benefits from the diversity of the people involved, diversity in ethnicity, gender, or abilities, for example. And also astronomy as a means to foster inclusion and development worldwide. The panels can be downloaded from the Inspiring Stars website if you are interested in recreating the exhibition at home. Inspiring Stars also includes several interactive stations, and here are 3 examples of them. One is a computer display that translates astronomy measurements into sound, made by Beatriz Garcia and her collaborators. Another one was a tactile model of the Japanese telescope Subaru, made by Kumiko Usuda Sato. And the third one is a multisensorial representation of the invisible universe that you can perceived through sight, touch, and hearing, made by Stefania Varano. Our contributions to this exhibition were the 3D tactile globes of 2 terrestrial planets, Venus and Mars, and also a tactile model of the Moon. They were specially designed to allow the blind and visually impaired to explore by themselves the most relevant features of the celestial bodies. So the final models were put to test by blind and visually impaired astronomers and also users from the general public. And the feedback that we gathered allowed us to improve the tactile planetary globes. Today, I wanted to share with you how we created these tactile globes, and I hope that this will help you to create your own models. The story is one of a somewhat complex journey. Our first approach was quite rudimentary. First, we started from a visual map of the Moon obtained by NASA's Clementine probe. We wanted to reproduce the visual experience into a tactile experience. So that is why we did not use topographical data in this case. We enhanced the contrast in the image to have a larger contrast also in the final tactile model. Black pixels were assigned the 0 height in the tactile model, and the whiter the pixel was, the taller was then in the final model. Then we smooth out minor features because an excess of details in the final model would have made it confusing to a person touching it for the first time. Then we created an ASCII file from the image using IRAF because we are astronomers and we use IRAF. And that was the input for the 3D rendering software. In our case, we used MeshLab, which is free, but you can use any other that you like. And then after the rendering, we obtained the final 3D file. But the whole process was like a long and winding road, as the sun goes. It implied moving data through several different softwares, and sometimes this produced errors in the input files. Also, the 3D rendering softwares are quite difficult to learn, and all this together made that the whole process was quite prone to lead to 3D files with holes and other defects that made them non-printable. But then a friend decided to create a more friendly software to make the whole process more reliable and fast, and he called it Mapelia. So Mapelia is an open source code in Python that transforms maps into 3D tactile globes. We will start, as before, from an edited map of the globe that we want to reproduce, the Earth in the example I am showing in this slide. But this time we can choose the image format and also use maps with different projections, not only Mercator as earlier. Then we run Mapelia with that image as input. And when running Mapelia, you can also choose to include polar caps in the model, or the equator, or a meridian, or even select the amount of relief in the final model. And less than a minute later, you have a nice 3D file ready to be printed. Mapelia runs directly on a terminal from the command line, but there is also a graphics user interface version named Guapelia. And there are some extra codes that we have called Mapelia's friends, Pintelia, Polygoniza, and STL Split. Pintelia is a program to project maps into 3D spheres with the original colors of the map. You may have noticed that we have been using grayscale maps so far. But with Pintelia, you can also put colors into your final 3D file. Polygoniza, that takes files of 3D points as key files and joins them, these points, to form the faces of a quasi-spherical solid, an STL 3D file. And the STL split, that splits an STL into its north and south hemispheres. This is really useful because many 3D printers find it difficult to print a whole globe. And it's easier for them to print two separate halves and then glue them together in the end. So far, we have created the 4 rocky planets of the solar system plus the Earth's moon. On the top row of this slide, you can see the 3D files. And on the bottom row, you can see the pictures of the printed models. You may notice that they all have some features in common, like the polar caps or the meridians. And these are elements that help the blind users to orientate themselves through the models. This is all part of a larger project called A Touch of the Universe. At the project's website, you can find and download these 3D models I have just shown to you, and a couple of activity books to carry activities out with the models. Of course, the Mapelia software, and also some additional resources like a half sphere with constellations engraved on it that we use in a planetarium show for blind called The Sky in Your Hands. You can also find the original soundtrack of the planetarium show in English, Spanish, and Portuguese that you are welcome to use if you wish to reproduce the planetarium show. I will stop here. This is the link to the website. Please feel free to contact me if you have any questions or requests. Thank you very much for your attention.